Good morning. Welcome to the Yongsan Baptist Church English Sunday School class for June 26th, 2022. Time is flying by. I feel so old. We are in Unit 6 of our study on biblical creationism and looking up at the evidence from the heavens to support the biblical worldview. Today, okay, nope, participate. There we go. Today, we will continue this discussion about evidence from the heavens, and I wanted to start with a review a little bit of the fact that we've talked here before about worldviews, right? Worldviews are really what is at odds when we get into the concept of any debate, because your worldview determines your presupposition base, and your presupposition base determines how you interpret the same facts. And people with worldviews at odds, right, with opposing worldviews, will look at the same coffee cup on the same table and interpret it differently, because their worldview determines their presuppositions, which then filters their interpretation of the facts. So you cannot claim to, we've discussed this several times, but it is not something you should expect in life, to be able to convince someone else to change their worldview or change their mind simply with facts, right? Facts are not enough because they will interpret them differently than you, and the same facts that you think should convince them to change their mind will in fact embolden them in their own stance and continue to confuse them as to why it doesn't change your mind, because presuppositions, the foundation, is where the problem lies, right? When it comes to the topic of origins, there are really only two worldviews. There's the naturalistic, often called the atheistic worldview, and then the biblical worldview. So the naturalistic worldview starts with two assumptions: that nature and matter are all that exists. There is no supernatural, there is only the natural. And that everything can, and indeed must, absolutely must, be explained by time, plus chance, plus the laws of nature working on matter. That's the only way anything can be explained. And if it can't be explained that way, we just haven't discovered it yet. Okay. The biblical worldview, in contrast, also has assumptions. One, that the eternal, good, all-knowing, all-powerful, holy God exists, and that He created everything else exactly as He said. And two, that the Bible, what happened?
Yes, it was already up there.
It was already up there.
Yeah,
the Bible, God's completely truthful eyewitness testimony, explains the key events in history so that we can correctly interpret the evidence from the origin and history of creation. So those are our assumptions because we have a biblical worldview. These are man's assumptions from their naturalistic worldview. And those assumptions lead us to interpret the same evidence in different ways. Okay? And we'll see some of that play out. But just like we've talked about worldviews before, we've defined terms back over a year ago now. We defined terms that we were going to use throughout this course, and science was one of those terms. Remember that there are two types of science. There's observable or operational science, as it's called, and then there is origin science. Origin science is all theoretical because no one can observe it. No one, no matter their worldview, can observe what happens with origins. It's all theoretical, based on hypothesis. But where you get that hypothesis, right, is the foundation of your worldview. Operational science, or observable science, we do every single day. I think there's such a thing as gravity. I support my claim with an experiment that I can reproduce over and over and over. And that reproducing the same evidence with the same hypothesis creates a theory that eventually creates the law of gravity. Because we call it a law because we've never been able to refute it in the same conditions, in the same point in time, point in place. So the two prevailing worldviews then give us two prevailing theories about origins. I say theories because, again, we cannot observe origins, so these are theories. The naturalistic origin story is the Big Bang. It's the only one they have. Now, the biblical origin story is, of course, biblical creation, as outlined in Genesis. So, how did the universe come into existence? Was it by natural means or supernatural means? If by God, then how? Could he, as some claim, have used naturalistic processes to bring about the supernatural creation of the world? Or did he create everything we see in the heavens by the first 4 days of creation week, like the Bible says? These questions are central to our understanding of the purpose of our universe and the significance that we play within it. So the first question today is, did God use the Big Bang? Some Christians accept the claim that God used naturalistic processes, including the Big Bang, to create the universe. They would argue that they agree with secular, mostly atheistic astronomers that state that the stars and the planets formed by slow, natural processes over billions of years. With only one exception, these Christians believe that God's hand directed those long, slow, gradual, stumbling processes. Unfortunately, such views deny what the Creator himself has said about the creation of the universe. So we see here in this comparison chart, the Big Bang is diametrically opposed to the supernatural creation described in the Bible. Furthermore, there are many other differences between the Big Bang and the biblical account of origins. The Bible tells us that God created a heaven, earth, and everything within them in a span of 6 days. We don't only see that in Genesis chapter 1, we see that in Exodus 20:11. And then he rested on the 7th day, and that's actually the basis of our work week. 6 days of working and 1 day of rest. And that's Exodus 20 verse 8. In contrast, the Big Bang model claims that the universe and the earth formed over billions of years, and then Genesis tells us that God created the stars on the 4th day, right here. 4th literal day. 3 days after the earth was created. But the standard, in the Big Bang model, the stars existed for billions of years. 14 to 15 billion years of the Big Bang. 10 billion years ago there were stars. 5 billion years ago there was a sun. Then there was a molten earth about 4.5 billion years ago, according to their claims. I think the 15 might be a little high. I think it's closer to 14 right now, like 13.8, 0.9, somewhere around there. But it keeps changing. So when I was a kid, we weren't even at 4 billion for the universe, and now we're pushing 14 billion for the universe. And you have to keep making it older because that fairy dust of time fixes all the problems. We'll talk about some of those problems in a minute. But the Bible tells us that the earth was made from water, right? The earth was without form and void, right? And darkness fell upon the face of the deep meaning ocean. All there was water at the beginning, but according to the Big Bang model, it was heat. Everything was heat and fire and energy at the beginning. So much heat, as we'll talk about in a minute, that it created things we still can't explain. Can't use the word created. It resulted in things that we still can't explain. But in the model of creation, there's no heat at the beginning. God created everything in the heavens, including earth, including a sun, without massive excess heat, which is something we can't explain, we just have to believe, right? That God could speak something into existence that should have caused a lot of after effects and side effects that we see in today's observational science. But we have to remember that origin science operates under different laws than operational science. Okay? As we've said before, there is God's power in creating and God's power in sustaining the universe. His creative power, what he did to make the worlds, did not fall under the same natural laws that what he does now to maintain the universe. Okay? There are two separate powers, two separate times, two separate sciences, and if you look at it from that perspective, then it makes more sense that certain things about origins won't fall in line with things that you observe today. Okay. The standard secular model teaches the Earth began as a molten planet that cooled over millions of years, somehow, and that the oceans were the result of either asteroid or meteor impacts, or from the dissolution or dissolving of comets as they entered Earth's atmosphere. So that's the general explanation for how we got water on the planet from molten rock, which came somehow from just pure gaseous energy, which came from explosions where we started with nothing. Okay, we easily see from Old Testament passages like in Exodus and in Genesis, Genesis 1, 2 through 9, Psalm 24, 2, and then 2 Peter 3, 5. So we have both Old Testament and New Testament examples, how the scriptures show that the Big Bang as a cosmological evolutionary theory is not compatible with the biblical worldview. I will say that again. The Big Bang is not compatible with the biblical worldview. The God of the Bible does not need billions of years of chance and delay to make the earth that he claimed he made in 6 days. And he made the stars also. If you haven't read that, we read that I think last week, maybe the week before, the fact that God in his account of creation in Genesis chapter 1 relegates everything in the heavens to those 5 words. And he made the stars also. Okay? But we're going to keep spending the rest of this time looking up at all of these things that captivate humanity and create all kinds of theories about aliens and life on other planets and time travel and all these other concepts that we've come up with because we're captivated by what's out there that we can't reach out and touch. Because we've spent a whole year studying the things we can reach out and touch here. And we're going to look at those things for a little bit. So the Big Bang model, how did it become the prevalent or dominant view? That's the next little subject here. Because what we're referring to this is as a cosmology. So a cosmology is a study of how we determine origin of the cosmos. Okay? So cosmology is separate from astronomy because cosmology would be the entirety of everything, all known and unknown, all of existence in the universe. So it is the dominant secular model of cosmology. In order for evolution to stand as a theory, what we call evolution, right? The evolutionary worldview. There must be at least 3 types. You could also break it into 5 types, but there must be at least 3 types of evolution, or it cannot explain origins. It could stand as a current theory, but not as a overarching worldview, because it wouldn't be able to explain origins. So in order for evolution to encompass the entirety of what the biblical worldview does, beginning to end, and even after the end. In order for evolution to replace that, it has to speak to origins, and it has to speak to the end. Okay? So those 3 mandatory levels, or types of evolution, the one that we're most familiar with is biological evolution, and that somehow life came from non-life. Right? That usually takes up the majority of the evolution and creation debate. But the next level that has to predate that, has to preface that, is geological evolution. How did the Earth come to be? Because there can't be life from non-life on Earth if there's no Earth. So how did Earth get here? And why is Earth so different? And so that geological evolution is another tier. But before there can be an Earth, there has to be the cosmos. There has to be everything else, right? All the other planets, stars, galaxies. Earth can't exist without a sun, and it technically can't stay where it is without the other planets in the solar system balancing the gravitational pull to keep it exactly where it is. So the solar system is required for the Earth to be where it is, the sun is required, and then what else is required in all the other hundreds of billions of galaxies, right, that have hundreds of billions of stars in so that's cosmological evolution, right? So this is where we're going to spend the majority of today focusing on, right, because we've talked about this before, and now we're here. Cosmological evolution, which would have to be the beginning in order for evolution to exist as a theory, again, from beginning to end. So the Big Bang model, originally based on what was called the cosmic egg hypothesis, if you've heard of that, it predicted that the universe ought to be filled outwards somewhere. It ought to be filled with microwave radiation at a temperature of only a few Kelvin. So Kelvin is the scale of temperature that goes from absolute zero, where matter cannot move, where it ceases to exist, right? So 0 Kelvin is literally as cold as anything can be. It's called absolute zero. And then all the way up to as hot as we can imagine, right? So Kelvin is a scale of temperature that would allow you to measure matter not moving to matter moving so fast it melts everything around it. Okay. So that on the Kelvin scale, we would expect this microwave radiation to be out in the rest of the universe around us as sort of a background. They call it the CMB, the cosmic microwave background. So their models predicted that there would be such a thing as this cosmic microwave radiation hovering around in space. Eventually, in 1964, they discovered the CMB. It actually exists. And this was the first successful prediction of the Big Bang model. And because the Big Bang model predicted the thing that came to be, it now had more clout, more validity, right, as a theory. And it passed some of the other theories like the steady state model or the eternal universe concept, and it passed all of those in popularity and became the most popular of the naturalistic cosmologies. At that point, it was still at odds with the biblical worldview, but evolution as a theory and as a concept from the mid-1800s to the mid-1900s was gaining a lot of ground. At this point in 1964, American textbooks had already been required to teach evolution for about 10 years, right? So we'd already passed the concept of Sputnik beat us to space, so Russians teach evolution. Obviously, we have to teach evolution. So we've already started trying to change the worldview of the Western world. But 1964, they made this prediction, and so then they became the most popular, but ironically, it was a staunch opponent of the Big Bang Theory, who was actually a steady state model, a proponent. He created the term Big Bang Theory as a denigrating term, as an insult for those people who believed in the cosmic egg hypothesis, and it stuck. So they took the name that he used to make fun of them, and now that is what everybody uses, is the Big Bang Theory. As it turns out, the CMB, the cosmic microwave background, was the only successful prediction of the Big Bang model. To date, they've predicted nothing else correctly with their previous models. And there are many problems even with that part of their theory. For every problem that crops up, a new, I think I have this here. Yes. For every problem that crops up, they have to create a new rescue device to change the theory to be able to continue to believe what it is they believe. And rest assured, this is a belief, because you can't prove anything with origins, so you have to believe it. So then the Big Bang model is proposed in 1948, 1964, they discover the CMB, now they become the dominant theory. But then there are problems, like the horizon problem, and the flatness problem, and the smoothness problem. And these are really complicated. I didn't want to get into them today to try to show graphs, but basically it's effects of what the CMB does, and whether it matches up with the billions of years concept, right? So these problems cropped up in 67, 69, 79. So in 1980, they come up with the concept of inflation to solve these problems. And I don't mean inflation like our money's not worth anything anymore. I mean inflation like they're trying to say that the universe, not even microseconds after the Big Bang initiated, massively quickly expanded in what they call an inflation model. Anyway, we'll talk about that in a minute. But so this problem comes up, and then they find that it's too smooth, and they've got to do another thing where they basically throw the data out and say, oh no, that was bad data. Obviously, the theory has to be right, the data's got to be wrong. And then they come up with more problems, and then they have to have more rescuing devices, and more problems, and more rescuing devices. Okay. So the problem is that the new additions, these new rescuing devices to save the paradigm, right, the way of thinking, there's no proof for any of these devices. No empirical data to refute the problems that we're about to bring up. These are obviously not all of the problems with the Big Bang Theory, but these are some that they have no actual data to refute. Okay? So the first problem with the Big Bang is missing monopoles. A monopole is in contrast to a dipole, right? Every magnet that you see on Earth is a dipole magnet. That means it has a north and a south, right? And when you try to put those same sides together, they will repel each other. You try to put opposite sides together and they will attract. A monopole magnet, if such a thing existed, would mean it's all around in every direction, only one pole. So there is no north and south dipole in a monopole magnet. The theory, hypothetically, a monopole, not a monopole magnet, but a monopole, is a hypothetical massive particle that's just like a magnet with only one pole, but it would have either a north or a south, and never both. It could be either one, but it would never have both. The particle physicists claim that the extremely high temperatures, good morning, the extremely high temperatures of the Big Bang must have resulted in the creation of these magnetic monopoles, right? Since monopoles are predicted to be stable, they should last forever. And if they should last forever, they should last at least 13.8 billion years since the supposed beginning of the universe. Despite considerable searching, no one has ever found a monopole particle in the universe. The fact that we don't find them strongly suggests the universe was never as hot as they claim it to be. So this indicates then that there might not have ever been a Big Bang if it was never as hot as the Big Bang would have required it to be. But the lack of monopoles is not problematic for the Bible's account, because God didn't say in His Word that He used massive amounts of heat to bring everything into existence. It says He used His Word to bring everything into existence. Okay, the next thing is too little antimatter. Okay, I'll click it again. There we go. Too little antimatter. A second scientific problem with the Big Bang is antimatter. If you've ever heard the term antimatter, you've probably heard it if you've watched Star Trek, but they never really explain what it is. So the Big Bang model proposes that matter in the form of hydrogen and helium gas, those are the lightest elements, that's what would have existed in the beginning. Hydrogen and helium gas was created from energy as the universe expanded from nothing into everything. However, experimental physics tells us that whenever matter is created from energy, such a reaction produces antimatter. So when you create from energy an amount of matter, you should have equal parts matter and antimatter. That's how energy turned into matter works in theoretical physics. The Big Bang should have produced equal amounts of matter and antimatter. So if it was true, we should find in our universe equal amounts of matter and antimatter. But in the visible universe, it is by far and away almost entirely consistent of matter and very few sparse traceable amounts of antimatter. So if we can't find the equal amounts of antimatter, not even anywhere close to it, this is somewhere around like the 98th percentile of everything that we've seen in the visible universe is matter. Very, very little of it is antimatter. We know it exists because we have detected some of it, right? That's how we started theorizing it in the first place, was we detected something that seemed weird. And what it is it's an equal and opposite, right? It is, if the protons and electrons in matter are positive and negative respectively, in antimatter, they are negative and positive, respectively, right? The proton being the largest, and the central element in antimatter, it has an opposite charge, right? It is everything literally the opposite of it. The only way they could explain it is if the universe was somehow split, and that there is an antimatter universe and a matter universe, and we're only aware of the matter universe. And so there's slight little leakages beyond it, because it's chaos in the Big Bang and you can't control it. So if there were two separate universes that never had any knowledge of each other, then maybe the antimatter is all over there and the matter is all over here. But again, that's all theoretical. There's no evidence for this. A third problem, no population 3 stars. The cosmology of the Big Bang has the problem of no population 3 stars, and then I'll explain this quickly. The Big Bang model by itself can account for the existence of only the 3 lightest elements, hydrogen, helium, and trace amounts of lithium. Those are the only 3 that the Big Bang as a model can account for. So all of the heavier elements, if you've seen a table of elements, right, we have over 200 more elements than this. And you can only account for those first 3 within the Big Bang, but it leaves other naturally occurring elements like carbon, oxygen, nitrogen that we have to live, right? Those other elements are unexplained. Since the conditions in the Big Bang model are not right to form these heavier elements, secular astronomers believe that the stars themselves produced the remaining elements by nuclear fusion in their core when they they distribute those heavier elements into space when they explode or go supernova. Right? That's the prevailing theory. But second and third generation stars are thus contaminated. Right? So the first generation stars would be all population 1 stars, as we call it, would be all helium, hydrogen, and a little bit of lithium. Right? That's what can be explained in pop 1 stars. Pop 2 stars would then be contaminated with these heavier, according to the theory, would be contaminated with these heavier elements that are produced by fusion in the core. And then, if this were true, the first stars would be comprised of only the 3 lightest elements, since they would have been the only elements in existence initially. And then some stars, right, it would continue to build up. Here's the struggle. Some such stars, right, that could be population 1 only containing 3, should still be around, because their lifespan, just like a monopole, is expected to exceed 13.8 billion years that have supposedly elapsed since the Big Bang. And those stars, sorry, I've got it reversed. The population 3 stars would be the ones with only those original 3 elements. Population 2 stars would have slight contamination. Population 1 stars would have all of the elements. Right? That's the way this should go. We should see population 3 stars with only those initial 3 elements, and yet we found none. There have not been any anywhere in all of our studies in all of the years. It's been over 60 years that we've had the ability to look out in space and test things as, SETI, the Search for Extraterrestrial Intelligence, has been searching for at least 60 years to try to find any sign that there's anyone out there, and they found absolutely 0 evidence. None. Absolutely none. So, the fact that we have no evidence of population 3 stars that should still be in existence if the Big Bang were to have created those first stars from a cosmological evolutionary perspective, we have no evidence of that origin story. Next, I talked a little bit about inflation earlier. So cosmic inflation is the concept that the Big Bang, and trying to keep this simple, again, there are lots of really complicated things that I had to swim through to find some simple terminology to try to bring this back. But according to the Big Bang model, the universe suddenly appeared 13.8 billion years ago. Don't break on me. 13.8 billion years ago, when all the nothing in the universe collapsed into a singularity and then exploded into everything. But according to this model, that beginning was a very dense, hot state that expanded into the universe that we see today. Cosmologists realized there were problems with the cosmic microwave background. Like I said, lots of problems with that CMB. It doesn't really fit their theory. And one of them was the horizon problem. Okay? So what they observed was that opposite parts of the sky, way out as far as we can measure, right? Opposite parts of the sky have identical temperatures in the CMB. And precisely identical temperatures. And that those opposite positions would not be able to have precisely the same temperature unless they were in contact with each other at some point before they were stretched out, as the Bible says, right? So in order to reach that equilibrium, they had to have been in contact with each other at some point. And that's the horizon problem in a nutshell. So a theoretical physicist named Alan Guth suggested that cosmic inflation was the solution for this. And according to his theory, just after the Big Bang, exactly 10 to the minus 34 seconds. It's an immeasurably short amount of time. It's all theory, like I said. The universe briefly, extremely briefly, and then rapidly expanded from that point, far faster than the speed of light, again, immeasurably fast. It was an immeasurable amount of time that it was all in contact after the explosion so that it could reach temperature equilibrium on opposite sides of the explosion that was about to happen, and that expansion, because of the massive amounts of energy, took it farther flung than it could possibly go in any known observational science track. And this would allow that the entire universe initially was in thermal contact, so it could reach that thermal equilibrium before it was pulled apart by inflation. The only problem is there's absolutely no evidence for that. It's a fairy tale. Again, most hypotheses are considered fairy tales until you find a way to prove them. But on that last chart, remember when inflation was recommended? It's been almost 40 years. They still have no evidence for that theory. But it is the prevailing theory because it's the only thing that they can logic into their theory to explain the problem that everybody knows is a problem. And most of this concept of the Big Bang and expansion and cosmological evolution from the beginning through the different processes to the galaxies we have flung out today, oddly in this photo they all look generally the same. But if you were to actually look at images of the galaxies, they don't look the same. Some are spirals, some are not, some are going one direction, some are going the other direction. It's chaos for the theory to be able to try to explain all those things. It's perfectly easy if God spoke it all into existence and just wanted it to be diverse, right? Because he programmed diversity into all of us so that we could look different, sound different, act different, want different things, do different things, right? Because he likes options and diversity. God loves diversity. Don't let anybody tell you any different. Okay, next problem. I like this one because it's going to confuse a lot of you just from the title. The axis of evil and the cold spot. So a fifth scientific problem, and this is simply for flair. This has nothing to do with the actual axis of evil and the cold spot. There's just a great little dichotomy here of hot and cold. That's all this is for. Okay, so the fifth scientific problem with the Big Bang is the twofold hot and cold problem. Real short, I'm going to say this. There are certain regions of the cosmic microwave background that one is called the axis of evil. I don't know why they got so dramatic with this, but it's a very large spot that is hotter than expected. It's too large of a spot to just be considered a variable, and it cannot be a cosmic